Ever wondered how clustering algorithms like k-means and k-medoids work? These algorithms are all about grouping data into distinct clusters. They are like the sorting hats of the data world, partitioning datasets into k-clusters. K-means does this by using the mean of all data points in a cluster, while k-medoids chooses an actual data point as the cluster center. Intriguing, isn't it? So how do these algorithms operate and what makes them different? Let's dive deeper to understand how each of these algorithms works. Firstly, we have the k-means clustering algorithm. The essence of k-means lies in the concept of a cluster center. This center is the average or mean of all the data points in a given cluster. Let's delve into the k-means algorithm step by step. The algorithm begins by initializing k-cluster centers randomly. This is our starting point. Next, each data point is assigned to the nearest cluster center. This assignment is based on distance measures, with Euclidean distance being the most commonly used. Once the data points have been assigned to the clusters, it's time to recalculate the cluster centers. The new cluster center is now the mean of all the data points assigned to that cluster. This step is crucial, as it moves the cluster center closer to its optimal position. The algorithm then repeats the process of assigning data points to the nearest cluster center and recalculating the cluster centers. This iterative process continues until the algorithm converges. Convergence is achieved when the cluster assignments no longer change significantly, meaning our clusters have stabilized. So we start with random cluster centers, assign data points, recalculate the centers, and repeat until stable. This iterative process allows the k-means algorithm to effectively group data into distinct clusters based on their similarities. So that's how k-means algorithm clusters your data. But what about k-medoids? Now let's move on to the k-medoids clustering algorithm. Unlike k-means, which uses the mean of all data points in a cluster to define its center, k-medoids selects one of the actual data points as the cluster center, or medoid. The medoid is the data point that minimizes the sum of dissimilarities between it and all other points in the cluster. Let's walk through the k-medoids algorithm. We start by randomly initializing k-medoids. Each data point is then assigned to the nearest medoid, similar to k-means. But here's where things get interesting. For each pair of medoid and non-medoid data point, we perform a swap and calculate the total cost, which is the sum of dissimilarities. If this swap results in a decrease in total cost, we keep it. We continue this process of swapping and calculating until no further improvement can be made. While this might sound a bit more complex than k-means, the advantage of k-medoids is its robustness to outliers because it uses actual data points as cluster centers. It isn't heavily influenced by extreme data points, making it a more reliable choice in certain scenarios. And that's how k-medoids works. But how do they differ? Now that we know how both algorithms work, let's compare them. K-means uses mean values for cluster centers, making it susceptible to outliers. On the other hand, k-medoids utilizes actual data points, showing more resilience to outliers. However, k-medoids has a higher computational complexity, especially when calculating the total cost for potential swaps. If you're dealing with a large data set and outliers aren't a concern, k-means is your best bet. For smaller data sets where outliers matter, k-medoids should be your go-to. So whether to use k-means or k-medoids depends on your specific needs and dataset characteristics. Happy clustering!